All right, so you've written some Java code, but have you ever stopped to think about how that program actually talks to anything outside of itself? How does it connect to a server across the world or pull data from a huge database? Well, today we're breaking down the two main ways Java connects to the outside world through networking and something called JDBC. And hey, if you're prepping for exams like the NPTEL, this is going to be super important.
So let's ask the big question. How does a running Java program communicate? I mean, on its own, a program is kind of like a brain in a jar. It can think, but it can't really interact with the world. To do anything useful, it needs a way to talk. We're going to look at the two big pathways it uses: networking to chat with other programs, and JDBC to have a conversation with databases.
So here's how we're going to tackle this. First, the basics of networking. Then we'll get into the big debate, TCP versus UDP. After that, we'll switch over to JDBC for all your database needs, and we'll wrap up with the key things you absolutely need to remember for any test.
At the highest level, you can really split this into two main jobs. If your Java app needs to talk to another app, maybe running on a totally different computer, that's networking. But if it needs to pull, say, user profiles or product info from a big organized data store like a MySQL database, that's a job for a special tool called JDBC.
Okay, before we dive into the protocols, the rules of the conversation, we need to talk about the addresses. It's just like sending a letter, right? You need a street address, maybe an apartment number, and a specific person to send it to. Networking has its own version of this, and there are three parts you've got to know. First up, you've got the IP address. The simplest way to think about this is as a unique street address for any computer on a network. Every single device, from a giant web server to your smartphone, has one. It's how we find the right machine in the first place. But an IP address just gets you to the right building, the right computer. What about the right application inside that computer? That's where the port number comes in. It's like an apartment number. For example, web traffic usually goes to port 80. This little number makes sure your data packet doesn't just show up at the front door, but gets delivered to the correct program. And here's where it all comes together. When you combine an IP address with a port number, boom, you get a socket. This is the actual communication endpoint. It's the thing your Java program creates to send and receive information. Think of it as the specific phone extension to a specific desk in a specific office building. Okay, now that we have our address, how do we actually send the message? This brings us to the two heavyweights of networking, TCP and UDP. I love this analogy. Think of TCP as a phone call and UDP as sending a postcard. One is all about reliability, the other is all about speed. This chart right here is gold. On the left, TCP, our phone call. It's connection-oriented, meaning it establishes a solid connection before sending anything. It's reliable, it guarantees every packet arrives, and in the right order. But all that checking makes it a bit slower. Now on the right, UDT, our postcard. It's connectionless. You just write your message and send it off. It's way, way faster, but there are zero guarantees. Now for exam purposes, burn these classes into your brain. Server socket and socket go with TCP. Datagram socket and datagram packet go with UDP. Let's see what this TCP phone call looks like in code. The server creates a server socket on a specific port, which is basically like waiting by the phone for a call. And that accept method, it does exactly what it sounds like. It just sits there and waits for a client to connect. Once it does, a brand new dedicated socket is created, and that reliable two-way conversation can finally start. And now, just look at how different UDP is. It's a fire-and-forget missile. You basically just package up your data, the destination address, and the port, into a datagram packet. That's your postcard. And then you just send it. That's it. No waiting, no connection, just pure, unadulterated speed. All right, let's change gears. We've talked about programs talking to programs, but what about a program talking to a database, like MySQL or Oracle? For that, Java has a secret weapon, JDBC, which stands for Java Database Connectivity. Seriously, just think of it as a universal translator that lets your Java code speak the native language of pretty much any database out there. The way this works is actually pretty brilliant. Your Java app makes a standard request. Then, the JDBC driver, and this is the real magic, translates that request into the specific commands that your particular database understands. Why is this so cool? It means you can switch your database from, say, MySQL to PostgreSQL, and you barely have to change any of your Java code. You just swap out the driver. So what does it actually take to use JDBC? Well, it's not a single command. It's a very specific step-by-step process. Getting this sequence right is absolutely critical. And I promise you, it's a classic exam topic. So let's really focus on this next slide.
This is it, the 6-step recipe you have to follow every single time. 1. Load the driver. 2. Establish the connection. 3. Create a statement object. 4. Execute your SQL query. 5. Process whatever results come back. And 6, and please, please don't forget this one, you must close the connection to free up resources. Seriously, memorize this flow. You are going to see it again.
Okay, that was a lot. Let's boil it all down. If there's just one thing you take away from this whole explainer to help you revise, make it what you're about to see. This table right here is your ultimate cheat sheet. It puts everything side by side. TCP, reliable communication. UDP, fast communication. JDC, database communication. Look at the key traits, and even more importantly for your exams, look at the core classes for each one. This is the slide you screenshot before your final exam.
So really think about it. The next time you're watching a live stream or playing an online game, that's almost certainly fast and loose UDP making it happen. When you do your online banking, that's a rock-solid, reliable TCP connection protecting your transaction. And when you're scrolling your social media feed, that's likely a whole bunch of JDBC calls fetching that data from a massive database. Now that you know the building blocks, you can see them everywhere. What other apps do you use, and which protocol do you think is running under the hood?